let's see what each of these functions does. Uh, we call this when the idle state starts. What we do is that we set our position, our character position, to what we set as our ground position in the vertical axis. We have that set to 0 here. 0 is our position, our default position for a character. So in idle we start with that. This method is going to be called as soon as we start our finite state machine. Here we have a timer that we use to count the 4 seconds before going to the waiting state. So we set a wait delay. Our wait delay is a value we have in here. Then we can set up the inspector in here. So going back to our method, and here we set our material, our idle material using our torso render reference that we have. Here we have a reference that we set up using our inspector here. We have the torso, and the torso has a renderer script that we reference. Here we also reference the feed particles that we will activate on the moving states. And here we have the materials that we got in our project, and we drag these materials to our inspector, so we have a different material for each one of the states. Alright. So while we are in our idle state, we are going to call idle update each frame, and we are going to use this method to detect if our character jumped. This is if we pressed our up arrow that frame. If we pressed our up arrow, we are calling the jump method, and we are returning true that we jumped. When you call jump, you are going to send the jump event to the finite state machine. I created a method for each one of the events, so I don't have to call this, and I directly use the method. So for each one of the events, I call these methods. And then if I didn't jump, I check. No, sorry, I'm not in the right method here. So I handle the ground movement input if my character didn't jump, and while what this does is that I check if my right arrow or left arrow is pressed, and then I use the move right method that will send the move right event. And if I've moved left or right, I set move to true, and I return that, so we can know if our character moved that frame. So we do that in here. We rotate towards back. Our character, our back vector goes towards the camera. So the character will look to the camera. We are here using some basic math functions of quaternion rotation. We create a target rotation using our direction. Here we get the rotation we want, and then we use slurp to rotate slowly toward that rotation, and we use the move rod speed that we can set via the inspector. Here we have our current rotation and our target rotation, so we're going from this rotation to this one using this speed. We always multiply the speed with time delta, so our speed is does not depend on the frame rate but on our time, because delta time is the time that passes between frames. And this move root speed, we have it in here, and we set this in here too. We have 20. Here we have 2. Let's change this to 20 so it's the same. Okay. So we are in here. Here we subtract the time. So as we set the delay in here at 4 seconds, if our timer goes to 0, then we call wait. So we send the wait event to our finite state machine, and we go to the waiting state. As we enter the waiting state, we call this method and we set the waiting material. Here in waiting update, we use the same method to check if our character jumped that frame or if we used a move input. If not, then we are creating a rotation delta using a scene movement. We have these factors in our properties, so we can control how our character moves in waiting. If the amplitude is greater, the character will have a greater inclination when moving back and forth, and if we increase this factor, the character will move back and forth with more speed. And we use the time since level loaded as our scene parameter. And then we rotate our character using that delta, and this will result in our character moving back and forth as you saw in the waiting state. So if we then happen to move right, we are going to enter the moving right init function at the start of our state, and we are going to set the moving right material, and we are going to activate feed particles. Each frame while we are moving to the right, we are going to check if our character jumped. If not, we are going to check if we are still pressing our right arrow. And if we are pressing our right arrow, we are going to create a delta position that will depend on our horizontal speed that we can set via inspector, and we will multiply that for our delta difference between frames, that is the delta time. Then we increase our position using that delta. We check with our sight distance limit if we are going beyond our limit. We are setting this limit in here. It is 5. I don't know if I have a different limit here. No, sight limit. When our character moves, it's going to move here and here. Those are the limits that we are checking in here. So here we are setting that. We are checking our limit, and if we go past that limit, we reposition our character so it is standing in that same value. We also use this method handle scene movement, that we also use an amplitude factor and a frequency factor, so we can control how high and low our character goes when he's moving, and how fast does the character move up and down. And we position our character using that delta. Okay. And we also rotate towards right when moving right. We already saw how this method works. And if we are not pressing the right arrow, we are going to go to our idle using rest.